Welcome to my garage on a nice, cool Saturday morning. And I have the privilege of walking you through 4.6, Prove Triangles Congruent by ASA and AAS. So let's back up and try to remember what we're talking about here. We're talking about triangles and proving that two triangles are congruent. And remember, we could do all 12, measure all 12 different aspects of these two triangles, and then ensure that corresponding parts of these triangles are congruent. And we could measure all three pairs of these sides, all three pairs of these angles, in order to prove that they are congruent. Because that's what you're saying. When you're saying that two triangles are congruent, then you're saying all three pairs of the corresponding sides are congruent, and all three pairs of corresponding angles are congruent. That's a lot of work, though. So we created these theorems, or other people have created these theorems for us to make things easier for us. And like I showed in class to you, that if I can prove that I have three pairs of congruent sides, that is sufficient to prove that these two triangles are congruent. I do not have to measure the three pairs of corresponding angles. All I have to do is measure the three pairs of congruent sides, and that's sufficient. That is side, side, side. Or I could figure out that, or measure, or determine that I have two pairs of congruent sides and the included angle. In other words, the pairs of angles that are the included angles. That is, those that are between the two sides. So here we're looking at one triangle. Here are the two sides come together, and this angle is between these two sides. Or you could say that this angle is created by these two sides. So that is the included angle between those two sides. So then if you have that, that is sufficient to prove that these two triangles are congruent, and that is called SAS. Remember, you do not want ASS. Do not be a donkey. Make sure that your angle is included. And then also on 4.5, with right triangles, all that we need is hypotenuse leg. We just need to prove that the hypotenuses the hypotenuses are congruent, and then one pair of the legs are congruent, and that's sufficient to prove congruence. So here we go. Now we're in 4.6, and we're looking at our last two. So on your notes, if you would write these five. I just ran through and did SSS and SAS and also HL. We also did HL, and now we're going to go through and do ASA and AAS. And if you have a reasonable understanding of these first two, then you'll be able to understand ASA and AAS. ASA is angle, side, angle, and AAS is angle, angle, side. So you're thinking, what's the difference? Both of them have two angles and one side. Well, you know, if I have the S between these two angles, then the side is the included side. So make sure you write that down. That is when the side, the pair of sides that are congruent are included sides. So here's a pair of angles that are congruent between these two triangles. Here's another pair of angles that are congruent between these two triangles. And I have a pair of sides, and these sides are the included sides. That is, they are between these two angles, or you can think of it as they are touching those two angles. So this side here is the included side between these two angles, or touching those two angles. In other words, if I had these pair of sides, that were congruent, that would not be angle, side, angle. In fact, that would be angle, angle, side. Whoops, I forgot to do the green on my thing. Do I have the marker? Do I have the green marker? I do have the green marker. Got to make everything exactly perfect, otherwise it'll have no difference to you at all. Sorry to take the time. But here's a pair of angles and another pair of angles, and here is a pair of sides. That's nice, but in this, oh, I just dropped my black marker. What a mess over here. But this pair of sides are not the included sides. So let's mark these up. I wanted for you to see them unmarked first, and then say, okay, what do I have here? So I have a pair of angles. So remember, I only mark one of these angles with a big old fat A. Here I have another pair of angles. So let's do another big old fat A there. And then I have a pair of sides that are congruent. So let's put a big old fat S there. So now the question is, do I have angle, side, angle, or do I have angle, angle, side? And it's rather obvious in this situation because the S is between the two angles. It's the included angle, and so this is ASA. As opposed to over here, I have a pair of angles there, and I have another pair of angles just like I did before, and then I have a pair of sides. Okay, so now, do I have angle, side, angle, or do I have angle, angle, side? And I have angle, angle, side because as I'm going around, think of it that way, I guess, going around the triangle, going from angle to angle, I do not cross that side, so that side, or this side here, is not the included side between those two angles, so I have angle, angle, side. So either way, either configuration, angle, side, angle, or angle, angle, side, both of these, either of these, let's say it that way, either of these are sufficient to prove congruence. It is just helpful to know and identify whether I have angle, side, angle, or angle, angle, side. Let's look at flow proof. Flow proof now. We are accustomed to the two-column proof, but I want to introduce you to a, wait, before I introduce you to a flow proof, let's do some examples. I forgot about that, sorry. And so here, I don't know what this is, looks like a catwalk or something, and we're trying to figure out whether we can determine that these two triangles are congruent. So what do I have with these triangles? I see I have a pair of angles. Let's put a big old fat A there, can't really see that, but here's a pair of angles that are congruent. I also have a pair of sides that are congruent, and so that's nice, but that's all that they give me. Is there anything else that I can determine, know that for sure are congruent? Yes, there is. See these two angles here? These two angles are congruent to each other. Therefore, I have a pair of angles. What am I saying? Those two are vertical angles. Therefore, they are congruent, and therefore I have a pair of angles that are congruent. Okay. So, what do I have? Do I have angle, side, angle, or do I have angle, angle, side? And I have angle, angle, side because this side is not the included side between those two angles. Let's do another one. What do I have between these two triangles? Up on the top left and the bottom right here, I see that they've told me that these two angles are congruent. So I'm going to mark the lower one. You could do lower one or upper one, doesn't matter. But let me mark the lower one. I have a pair of angles that are congruent. I have another pair of angles. Notice that I have two arcs, double arcs here, and also double arcs there. So those two angles, pair of angles, are congruent. And I also have, of course, these are vertical angles. They did not need to tell me that, but it's helpful. Nice hint that they told me. But because they're vertical angles, they are congruent. So I have a pair of another pair of angles that are congruent. So what do I have? I have angle, angle, angle. Is that sufficient to prove congruence. Is that one of my 5 theorems that I have here? And the answer is no. That is not sufficient to prove congruence. It is, we will learn later, it is sufficient to prove similarity, but not congruence. So these two triangles here, they might be the same, they are the same shape, but they are not the same size, or at least we can't prove that they are the same size. So I can say that they are similar, but I cannot say that they are congruent. So angle, angle, angle is not sufficient to prove congruence. Here I have 2 triangles, and it looks like this is like a diagonal, a structure, support interior beam there. And so I have single arcs there. So let me just mark the lower one. I have single arcs there. I have double arcs here. So here's another pair of angles. So I have 2 angles, 2 pairs of angles that are congruent. What else do I have? Hey, this side for the upper triangle is congruent to this side for the lower triangle. And what is the property of equality that we use for that? It is reflexive. So therefore I have a pair of sides that are congruent of these 2 triangles. And so do I have angle, angle, side, or do I have angle, side, angle? And the answer is angle, side, angle, because this side is the included side between those 2 angles. Let's talk about flow proof now. Where is flow proof? There it is. Flow proof uses arrows to show the flow of a logical argument. We are accustomed to a 2-column proof. Now we're just taking the same information but putting it into a different format. It's called the flow proof. We have cool arrows. Each reason is written below the statement that it justifies. So here's an example in your book. We're given these 2 triangles, and we're asked to prove that these 2 triangles are congruent. And make sure you read through the given. In this case, the given is written on your diagram, but when you read through the given, make sure that all of this information on the given is indicated on the diagram. So angle A is congruent to angle D. Here's angle A, here's angle D. Yep, I have a single arc there. Angle C is congruent to angle F. Here's C and F. I have double arcs there. That's sufficient to prove congruence. Or no, hold on. What am I saying? We're just told that those 2 angles are congruent, and so I'm marking that they are congruent. And then segment BC is congruent to segment EF. BC, where's BC? Here's BC, and here's EF. And so my diagram is marked with this given statement. Okay, so make sure you read the given carefully and ensure that all that information is indicated here on your diagram. Now our proof. Let's start out with angle A is congruent to angle D, and that is given. So here is the statement, and here is the reason. So in the 2-column proof, this should be on the left-hand side, and this guy would be on the right-hand side, but we just put them on top of each other in this flow proof. We are also given that angle C is congruent to angle F, and we're also given that these 2 segments are congruent to each other. So in this particular flow proof, they listed out the givens on top of each other. And then they're saying, okay, take this information, these 2 things, that the fact that these 2 angles are congruent, and because of these statements, we can say that angle B is congruent to angle E. So how can we do that? When you know 2 pairs of angles are congruent for a triangle, remember, we know that the 3rd pair of angles will also be congruent. Because the sum of the interior angles of any triangle is 180 degrees, then if we take away a particular angle from it and then another particular angle from it, then we know for sure that the remaining amount will be the same on both triangles. So that's called the 3rd angle theorem. That gives us the reason for why we can say this statement. And now that we have the fact that these 2 angles are congruent to each other, then combining all this other information with that, we can say that these two triangles are congruent based upon angle side angle. So here's a pair of angles that we are given are proven are congruent, and then we have a pair of sides that was also given to us, and then we determined that the what am I doing? Put S there. We have determined that these two angles are congruent, so therefore I have angle side angle. That's what they're saying here, angle side angle congruence. So one thing is to understand how we did that. Another thing is to understand the format that we are using to prove or to demonstrate that they are congruent. So that was example 2, and you are ready now to do example 1. In this diagram at right, write the postulate or theorem that you can use to prove that these two triangles are congruent. So it's going to be one of these, and mark up your diagram like I've done here with so you see here I have a pair of angles that are congruent, so make one of these. It can be the left triangle or the right triangle, but put a big A on one of these angles, and you see you also have a pair of sides. Wait a second, that's all you have though. Huh. Is there anything else that you can determine that pairs of congruent parts? I'll let you figure that out on your own. So go ahead and pause the video and do this, and then write. You must write like a sentence. Please write a sentence in here describing how it is that you can prove that these two triangles are congruent. It does not need to be a flow proof or a two-column proof. Just give me a paragraph proof. Just kind of write out why you can do that. Okay, pause the video and go ahead and do that. And then here's example 3. I have not looked at this yet. Let me see if I can figure this one out. Let me move this over here so I don't mess up my arrangement. Here we go. So in this diagram, segment CE is, what does this symbol here mean? It means perpendicular is perpendicular to segment BD. Okay, so I'm going to indicate that. I'm going to go ahead and put a square there because like I said, when you read this given information, put it on your diagram so all of your information is there on your diagram. And angle CAB, that's this angle here, is congruent to angle CAD, that's this angle up there. Okay, so I put single arcs on those two guys, indicating that they are telling me that those two angles are congruent. Now write a flow proof to show that where's A? A, B, E. Okay, so this guy on the left is congruent to this guy on the right. Okay, we can do that. And let me see if I can figure it out myself. What kind of a triangle is this that they are these? What kind of triangles are these that they want us to prove are congruent? They are right angles, right triangles. And so wait a second. Remember my different theorems? Which one in particular can I use for right triangles? I can use any of these, but which one can I only use with right triangles? HL, hypotenuse leg. So again, I can use these on right triangles, but when I have a right triangle, I'm looking for hypotenuse leg. In fact, that's what it says here on your geometry definitions and theorems. Where does it say that here? Number 5, keep this handy. This is a very useful reference. Number 5 says if you have right triangles, then used in a congruence proof, then look for HL, hypotenuse leg. So do I have hypotenuse leg? Well, what did they tell me that I have? I don't think I do. I have, because do I know that these hypotenuses are congruent? I don't know. It looks like they are, but I don't know that for sure. So, bummer, man, I don't. Here I was all excited that I might have that, but I don't. Okay, so, but I do know that these two angles, these pair of angles are congruent, and so I can determine that these two angles underneath them are also congruent. Because what is true about these two angles? I wish I had a bigger, could make this bigger for you. But you don't have it. So these two angles are adjacent and a linear pair. And so then if the top angles are congruent to each other, let me use my pen. If the top angles are congruent to each other, then the bottom angles are also going to be congruent to each other because they're both supplementary with each other. Okay, and then I do have a pair of sides here by reflexive So AE for the right triangle is congruent to AE for the left triangle. And so I have angle, side, and then I do have a pair of angles based upon that I was told that this right one, is that right? No, I was just told that they're perpendicular. And so, of course, it makes two right angles there. So I do have angle, side, angle. And that is sufficient to prove that these two triangles are congruent. I thought for sure they would give us hypotenuse leg. That's interesting. So they threw a curveball on us. Okay, so a flow proof of that is right here. And rather than take the time, well, I'll go ahead and do that, I guess. So first they give us that these two angles are congruent. That's given. And then congruent supplementary. Yeah, that's what I just said. Meaning, that's an interesting way of saying it. Congruent supplements theorem is what they're saying. I've not seen that as a theorem, but that makes sense, right? I explained that to you, that if the top ones are congruent to each other, then these bottom ones, which are congruent to the top ones, not congruent, are supplementary with the top ones, then these bottom ones will also be congruent, and that's called the congruent supplements theorem. And then the linear pair postulate, what is that? Oh, no. Okay, I'm sorry. So they're doing this way. That's interesting. So they're saying this first, and then that these dudes on the bottom are supplements of the top dudes, and then they bring it together. See how the flow's going? I didn't see the arrow direction here. And that's combined to say that these two bottom angles are congruent with each other. Now, once you have that, then you can say ASA, like I was saying before, because you also have the reflexive, that's this guy, angle, or segment AE, congruent to itself. Okay? And then once you have, why did they say A? No, oh, look at that. That's interesting. So this is kind of flowing down. Here I thought it was flowing to the left to right. Ah, these guys are crazy. Okay, so what they're saying over on the right side here are, yes, they're perpendicular, like I was saying, and then also the definition of perpendicular lines is they create right angles here, and then therefore those right angles are congruent, and then bring this in. Okay, so what they're saying is, here's the angle that they're bringing in, here's the side that they're bringing in, and here's the angle that they're bringing in. Okay, so they're kind of coming at it from all sides and coming down, and here's your final. So as you see illustrated, and as I painfully experienced just now, that wasn't painful, but we realize I'm learning, huh? Right? When there's pain, there hopefully is learning going on, and I'm learning that there's different ways of organizing your flow proof. You can either do it going left to right, like this guy was, or you can organize it going top to bottom. You do whatever way you want to. But in this particular case, you do not have to do a flow proof. All that you have to do is just determine whether or not these two triangles are congruent, and then tell me down here what theorem it is that you use to prove that these two are congruent. If you can prove that they are congruent. And also mark up these diagrams just like I've done here. So you're going to use one of these five. Alright, hope that's helpful to you. And may the Lord bless you, and look forward to seeing you in class.